This presentation will be the electron configuration for the element argon. First, we need to figure out how many electrons are in an argon atom. To figure out how many electrons are in an argon atom, we have to find the atomic number of argon. To find the atomic number of argon, we need to reference the periodic table and find the letter symbol for argon. Up close, we now see that argon's letter symbol is Ar. Once argon on the periodic table is found, you can look above the letter symbol to find the atomic number, which we see here that it's 18. Once the number of electrons are known, we can write out the electron configuration. To use this chart, we will start at the top and work down diagonally. Keep in mind the amount of electrons that each type of shell can hold. S shells can hold up to 2 electrons, P shells can hold up to 6 electrons, and D shells can hold up to 10. Next, we need to put all of the electrons into shells around the nucleus. Let's think about what we know. We know that argon has 18 total electrons, and we also know the electron shell totals. So knowing this, we can start putting the electrons into the shells that they belong. So first, we fill the first shell, which is an S shell. Again, S shells can hold 2 electrons, so we fill it to its max. We move on to the next shell, which is 2S, which can also hold 2 electrons, and we fill this shell to its max. The next shell is a P shell. P shells can hold 6 electrons. Since we need to get to a total of 18 electrons, we're going to go ahead and fill this shell to its max as well. At this point, we still only have 10 electrons, so we still need to keep going to the next shell, which is another S shell. We fill this one to its max of 2 electrons. Our final shell is a P shell. P shells, again, can hold up to 6 electrons. This is the final shell that we'll fill because we have a total of 18 electrons, which is the total amount of electrons that argon has. So this formula that we have here is the final electron configuration for argon.